Welcome to DC Broadcast Podcast, your direct community broadcast, your trusted source for education, entertainment, and everything in between. Stay connected, stay informed, and stay entertained. Stay tuned.
All right, everybody, welcome back. Ready for another deep dive.
Let's do it.
Awesome. Today, we're tackling a topic that's fundamental to, well, pretty much everything. Chemical reactions.
Yeah, can't really get away from them, can you?
Nope, they're everywhere. You guys sent in some really fascinating material on this, so we're going to unpack it all. What exactly are chemical reactions? How do they actually work? And why should we even care?
Right.
And I got to say, I love this idea of reactions being like a little hidden molecular dance.
Oh, yeah, it's a great way to think about it because really chemical reactions are the basis of everything around us, Air, food,
Yeah.
materials.
I mean, I remember learning about chemical reactions back in school, but it was always kind of like, oh, one substance turns into another, like mixing up ingredients to bake a cake, right?
Yeah.
Simple as that.
Yeah, that's a good analogy. But at a much, much smaller level, of course. So we're talking about the breaking and forming of bonds between, like, atoms and molecules. These tiny particles, they get rearranged, swap partners, and boom, you have a brand new substance.
So there's more to it than just mixing stuff together.
Oh, absolutely. It's not just a static change. It's a dynamic, ongoing process, constantly changing.
Okay, so that's where this whole molecular dance idea comes in, right?
Yep.
But it seems like some of these dances are super fast, like a quick step, while others take, I don't know, years to finish. Why is that?
Good point. That's where reaction kinetics comes in. It's all about how fast or slow these reactions occur. It's like, imagine trying to start a fire. You need a spark, right, to get it going quickly.
Right.
That spark is kind of like the activation energy you need to kickstart the reaction.
Okay, I'm starting to see the connection. And I'm guessing things like temperature and concentration
Yeah.
also play a part, right?
Yeah.
Like a hotter oven bakes a cake faster.
Exactly. Temperature gives the molecules more energy to move around, so they collide more often, leading to faster reactions and higher concentration. Well, that just means there are more molecules packed in a space, increasing those chances of bumping into each other and reacting. It's like a crowded dance floor, More likely to bump into a partner.
So we've got this crowded molecular dance floor where things are constantly bumping and changing partners. And speaking of partners, our source mentions 4 main types of reactions.
Oh, yeah, that's right.
Can we break those down? Starting with synthesis?
Synthesis is kind of like the construction crew in this molecular world. They're combining simpler molecules, the building blocks, to create something more complex. A classic example is the creation of polymers.
Polymers.
Yeah, those long chains of molecules that make up things like plastics. We wouldn't have so many of the materials we rely on without synthesis reactions.
Wow, so it's not just about mixing things in a lab. There are real-world applications like in material science.
Oh, absolutely. Huge implications. Now, on the flip side, we have decomposition, the demolition crew. This is where complex molecules are broken down into simpler ones. It's like, I think about composting. Dead plants and animals decompose, their complex molecules break down.
Okay, so we've got construction and demolition covered. What about single replacement? Is that where one element like gets jealous and cuts in on another?
Huh. I guess you could put it that way. One element swoops in and replaces another in a compound, like when iron rusts. Oxygen replaces iron in the metal, forming iron oxide, which is rust.
Ah, so that's why we need to protect things from the elements. All right, last but not least, double replacement. Is that where everyone on the dance floor just switches partners?
Pretty much. 2 compounds do a little partner swap, and you end up with 2 new compounds. It's like that square dance where everyone ends up with someone new by the end. Like, a simple example is when you mix baking soda and vinegar.
Oh, yeah.
They react to form carbon dioxide, water, and sodium acetate.
So that's the science behind those classic volcano experiments we all did as kids. I always loved those.
Yeah.
Okay, so we've covered the basics of chemical reactions, the different types, and what speeds them up or slows them down. But honestly, why should our listeners care about all of this? It seems like pretty technical stuff,
Well, that's where it gets really interesting. Because understanding chemical reactions is really about understanding the very processes that make life possible. For example, photosynthesis.
Plants, right.
Exactly. It's a complex chain reaction that lets plants convert sunlight into energy, and that energy forms the basis of the entire food chain,
Wow. And combustion is a chemical reaction too, right? I mean, that's how we power cars and generate electricity. Pretty important stuff.
Absolutely. Combustion is a rapid reaction between a substance and an oxidant, usually oxygen. It releases heat and light. But it's important to remember, not all combustion is good. The burning of fossil fuels, that's a major contributor to climate change.
So this knowledge about chemical reactions, it can help us make better choices about the environment too, then.
Oh, for sure. And even something like taking medication, that relies on chemical reactions too. Think about it. Pharmaceuticals are designed to interact with very specific molecules in our bodies, triggering the right reactions to treat diseases.
It's amazing to think that all these complex processes we see in the world, they all come down to, like, atoms and molecules doing their little dance.
It really highlights how understanding the microscopic world, these tiny reactions, can have huge implications for our big macroscopic world.
Absolutely. So to recap our deep dive today, we learned that chemical reactions are basically the foundation of everything, from life itself to the materials we use every day, and even medicine. It's all about molecules breaking and forming bonds, that constant dance happening all around us. And we've got different types of reactions, each with its own unique steps. And things like temperature and concentration, they can really affect how fast these reactions occur.
And as we've seen, understanding these reactions isn't just about memorizing terms from a textbook. It's about understanding the processes that shape the world around us.
Exactly. So next time you bake a cake, drive your car, or even just take a breath, think about that invisible world of molecules, constantly reacting, changing, dancing. Pretty mind-blowing, huh?
Yeah.
And on that note, we'll wrap up our deep dive for today.
Thanks for listening, everyone.
Thanks.
Thank you for tuning in to DC Broadcast Podcast. We hope you enjoyed today's episode. If you have any questions about the topics we covered or want to share your thoughts, visit dcbroadcast.com/askai. We'd love to hear from you and might even feature your question in an upcoming episode. Don't forget to share this podcast with your friends and subscribe to stay connected and never miss an episode. Until next time, stay curious and keep listening.